Hello everyone, and welcome to the Citrix Master Class. We hope you enjoyed the What's New webinar, which you can find linked in the description below, and we're happy to be able to dive further into the content for you. My name is Stephen Gallagher, a technical marketing architect at Citrix, and I'll be your host today. In this masterclass session, we will deep dive into Citrix uberAgent. However, before we begin, I want to make a few announcements. Our masterclasses this year will run quarterly and last approximately 45 to 60 minutes. We have some exciting content and speakers lined up to cover our entire portfolio, so make sure you tune in for the upcoming masterclasses. And thanks again for joining us. So let's get started. For today's masterclass topic, we will discuss how Citrix uberAgent UXM determines application reliability KPIs, finds issues with network connectivity, and collects detailed inventory information and shows which applications are used and how often. Just to name a few, small set of this impressive features. We'll also look at some of this uberAgent UXM comprehensive Citrix monitoring capabilities and how uberAgent's browser monitoring functionality provides detailed insights into web application usage and performance. I'm very excited to welcome Julian Cross, the lead product manager to the Citrix Masterclass. Welcome, Julian.
Hi there. Thanks, Stephen. Hi, my name is Julian Cross. I'm a product manager for uberAgent here at Cloud Software Group, and I'm happy to present this masterclass to you today. I'm working for uberAgent or with uberAgent for roughly 2.5 years now. And as the title already indicates, we're talking about uberAgent UXM in today's masterclass. And to do so, I've prepared a few slides, but I can already assure you that most of the time will be demo time. So let's have a quick look at the agenda. First, I'm going to share what uberAgent is. Then we'll see how it plugs into the Citrix observability stack. Third, I briefly describe the architecture of the agent. And finally, we're opening the floor for some live demos. So as you can see, we have a lot to speak about. But before we dive right into the content, I'd like to take a few steps back and share what uberAgent actually is. uberAgent provides visibility into everything relevant to end-user computing. This means that we are analyzing everything that could impact the user experience. But uberAgent is not limited to measuring the user experience. There's also a component to perform endpoint security analytics. So on this slide, we can see both components, uberAgent UXM and ESA. uberAgent UXM provides rich metrics around installed applications. That means that uberAgent is creating an application inventory, including usage reports and classical app performance monitoring. With this product, you can also determine network performance, even on a per process level. We can see which process was connected to which target and, for example, how much data volume went over the wire. In addition to this, uberAgent can monitor what's happening inside the browser. This is especially important as more and more business apps are shifted from classical installed applications to web apps. So these are just a few pieces that make up the functionality of uberAgent UXM. On the right-hand side, you can see uberAgent ESA, the endpoint security analytics component, which is built on top of UXM's metrics and extends the use case to endpoint security. With ESA, we are addressing multiple relevant areas for endpoint security. The first one is risky behavior. uberAgent ESA sheds light on risky behavior caused either by users or applications with its threat detection engine. This feature is a rule-based approach to identify exactly this risky behavior. So basically, you're informed when the agent identifies one of the predefined events. Another area ESA is covering is insecure configurations. Many attacks out there can be prevented if a good and secure configuration is applied. Therefore, uberAgent comes with a security and compliance inventory. This feature periodically checks whether desired configurations are applied, machines are compliant, and if the line of business application is set up properly. These are just two of the key security features that uberAgent brings to the table. There's much more to discover, but as you can see, both topics are very complex. Therefore, we're just focusing on uberAgent UXM in today's masterclass. Now that we have an idea of what uberAgent is, I'd like to cover how the product plugs into the Citrix observability stack. As you can see on this slide, Citrix has a variety of products for monitoring users and sessions. We have a director and monitor for real-time triaging and monitoring sessions. Then there's analytics for proactive monitoring. Finally, we see the NetScaler console for gateway and HDX insights. However, all of these components have something in common. They all require some kind of Citrix component to be involved. And that's exactly where uberAgent comes into play. uberAgent is an agent-based approach to monitoring system KPIs like CPU, memory, and network performance. Additionally, uberAgent creates software and hardware inventories. As I just mentioned, the same product monitors not only user experience related things, but also adds the security perspective with uberAgent ESA. So basically, two products within one software. What's even better is that you can install not only the product on Citrix session hosts, but also on physical devices like laptops or desktop computers. I just briefly described uberAgent UXM and ESA. Both products are combined in one single agent that is installed on the endpoints. So you install one software that brings a lot of value to your infrastructure. You can measure the digital user experience, perform application and machine performance. You can monitor web app performance. You get inventory metrics, not only for software, but also for hardware. And with the same product, you can assess your endpoint security posture. You can verify the compliance status and identify unusual behavior. When looking at these supported platforms, you can see that uberAgent can nearly be installed everywhere. So we're targeting single and multi-user Windows endpoints, remote PCs, and macOS VDAs. And of course, you can install uberAgent on cloud-hosted computers in Azure or AWS. And to conclude the platform support, I'd like to add that you can install uberAgent everywhere a Microsoft-supported Windows operating system is running or a macOS is installed. We've also just started working on an agent that can be installed on Linux to monitor, for example, Eagle thin clients. And if you want to evaluate what's happening inside the browsers, you can do so by additionally installing one of our browser extensions, which are available for Edge, Chrome, and Firefox. Once the agent collects the data, it sends it back to the backend of your choice. uberAgent offers a wide range of backend integrations. First, uberAgent can send its data to Splunk Enterprise, the on-prem option, or Splunk Cloud. But you could also send your data to Elasticsearch, Azure Monitor, Apache Kafka, or Azure Data Explorer. The data quality is the same across all backends, and you can send data simultaneously to multiple backends. However, Splunk is the only backend we ship dashboards for. This is just a brief overview of uberAgent's functionality and flexibility. Now let's speak a little about what uberAgent can do for you and how it can be used. We've identified 4 business outcomes for you. Improved employee productivity. By proactively monitoring your infrastructure and fixing issues before they lead to an outage, you can improve employee productivity. For example, if you have a fast-running infrastructure, your employees spend less time waiting for applications to start, user logins, or the machines to boot up. Maximize cost savings. By providing a fast-running and reliable infrastructure, you can reduce the time your users spend calling the help desk and complaining about the IT. Improve operational efficiency. So when your users spend less time waiting for the machines to respond or calling the help desk about poor session performance, you improve your operational efficiency, not just on the user side, but also on the help desk side. And finally, you achieve what everybody wants to improve, the employee satisfaction. Your users can do the jobs they are there to do, because uberAgent helps you deliver a good, fast, and reliable IT infrastructure. Now, as the last topic before we dive into the demo, let's have a quick look at the architecture side. The typical architecture includes two things. First, there's the agent itself you install on the endpoint. So the agent you install on your Windows or macOS based laptops, or also your VDI components. We strive to keep the footprint on the machine's resources as small as possible. Therefore, I'm happy to give you some figures. Roughly 50 megabytes of RAM and less than 0.5% CPU. The second part of the architecture is the backend. I've just mentioned that we support multiple backends, but Splunk is the only backend we ship dashboards for. Therefore, we have apps that get installed in the Splunk environment. Once the app is installed, you're all set. The data collected by the endpoint agent is sent to Splunk and is visualized on more than 70 dashboards. You could also customize the default dashboards as the source code is provided. This means you can tailor the dashboards to your needs and add other data sources to be displayed. So you can incorporate uberAgent data with other data sources you might have in Splunk. Now let's have a quick look at the typical deployment scenario. As you can see, we have the agent sitting on the endpoint. The agent collects the data on the endpoint and sends it directly to the backend. uberAgent does not require any middleware component, as it is capable of sending the data directly via TCP, HTTP, or HTTPS. Okay, so we have touched on what uberAgent is. Now let's see how the product can be used. Therefore, I'm going to switch to my demo environment. What we are now looking at is my local Splunk instance, and I've just opened the uberAgent UXM Splunk dashboard app. Before we dive right into the dashboard itself, I'd like to speak about the menu bar at the top, so that you can see from which angles uberAgent provides metrics. First, there's the machines menu. So you can see uberAgent provides metrics about the machine performance, but also around machine network, communication, configuration, but also highlights machine network issues. Then there are dashboards for step errors, so blue screens, or kernel panics on macOS, and uberAgent performs a machine inventory. Then the next menu item I'd like to speak about is sessions. So uberAgent monitors all sessions in the entire estate, and it also shows you the user logon duration, which we are going to look at later on. Then there are metrics about applications, like application performance, application startup, or browser web app monitoring. There's also an application inventory and the application usage dashboard. Next, we have dashboards about processes. So we separated applications and processes. I'm going to cover the reason for this later on. Then there are dashboards for on and off transitions, so boot duration or shutdown duration, for example. And especially for Citrix, Citrix use cases, we have several other dashboards here. We can also monitor the NetScaler appliances. Now let's focus on this dashboard, the Experience Score Overview dashboard, which is our entry point of the uberAgent UXM Splunk app. What we tried to achieve here is to create a dashboard that enables users to easily identify how the whole environment is doing. To do so, we created a scoring range from 0 to 10, whereas 10 is the highest score and 0 the worst. We also adopted a traffic light system, or the colors of a traffic light system, to represent those scores. So as you can see, our today's score, the overall score is 8.4, equals a good score. On the right, we can see how the score has changed over the past week. When scrolling down, we can see the 3 categories that are used to calculate this overall score. So we have a category score for machines, 6.7 here. Then we have a category user sessions where we see a score of 8.9 and category applications with a score 9.6. We also see a little trend indicator, so we already have an idea if it's getting better or worse. Those category scores are calculated by individual component scores. So there are components that are true for all categories, such as CPU, RAM, and disk I/O, but also specific ones like stop errors or disk space for machines, lock-on duration and protocol latency for user sessions, and, for example, network availability or app errors for applications. So when we scroll a little bit further, we can see which machines scored in which, let's say, scoring range. So we can see here, for example, that we have 10 machines with a very bad score, 12 with a medium score, and only 1 with a good score. Those are the machines with their individual results.
So why are the machines score so low? So can we drill into those 10 machines to understand what are the facts behind that?
Yeah, certainly. You just click on the line and Splunk will open a time chart showing you how the scores have changed, or showing you how those scores were in the past hours. So let's focus on the worst score here, the stop error score. So we can see it dropped here at 8:30 a.m. And this already gives us a very important information. We know when the problem started to occur, right? Then we could rethink, okay, did we install Windows updates? Did we install another software that brings its own driver, for example? Or did something else change in the environment? Now, when we want to go a little bit more into detail, we just click the Analyze button here. And Splunk will take us to the single machine detail dashboard. Just give it a few seconds to load here. And then we can see some hardware information about this machine, like the name, obviously, but then also information about the hardware manufacturer, the model, the CPU base speed, the average CPU actual speed, how many cores are implemented in this machine, and how much memory is assigned. Then there's information about how many sessions from how many users are on this host and some average resource values here. When we scroll a little bit further, we can see how the machine score has changed over time with its individual component scores here. Then we see which users are currently connected or connecting to this machine. We can also see the protocol, the resource consumption of that individual session. And scrolling further, we have two additional time charts here. First, the network data volume and latency over time. So we can correlate the send and receive volume with the average send latency. And second, the CPU and RAM over time. So we can correlate these values as well. And this already gives us the ability to identify like outliers or spikes there. Then there's a table displaying all the applications that are currently used on this machine, also with their specific resource values. Then we can see the network connections made from this machine. So we see the target IP, which protocol was used, how many sends and receives we saw, and also how much data volume went over the wire. Scrolling a little bit further shows us the table for which we came here, the stop errors table. So when we circle back to the experience score dashboard, we remember that we saw a very low score for stop errors, and this is the information we are looking for. All those stop errors with their individual parameters are listed here that are highly valuable for the further troubleshooting.
Okay, thanks, Julie. So during the introduction and the overview of the uberAgent, you mentioned that it creates like a machine inventory. So what does that look like?
Yeah, good question. Let's just dive right into the dashboard. So it's located under machines here. Just click on the machine inventory and then you get to this dashboard. So at first it creates some top 10 charts so that you can see which are the most popular hardware models and operating systems in your IT infrastructure. And scrolling further shows you the inventory data grouped by hardware model. So let's have a look at my notebook here, the ThinkPad T14S. Just click on it and Splunk will show you a little bit more detail about this machine. And if you want to dig deeper, just click on the host name and Splunk will show you the single machine inventory dashboard. So then we can see some really detailed information about this machine, like the ID domain net BIOS. We can see the BIOS serial number, BIOS version, information about the CPU, also which CPU is implemented here, what was the hardware manufacturer, which model is it, if the device has battery, if the device has a hypervisor installed. In my case, I have Microsoft Hyper-V installed. Then we can see if the machine is a VM or not. We also have information about which monitor is attached to this device. So in my case, it's a widescreen monitor. Then there's information about the network connection, like which adapter is currently being used, also with the IP address and the MAC address. Then there's information about the operating system, not only the name of the operating system, but also the installation date or the build version. And then we can see which applications are installed on this machine. We can see the version, the install date, which language was installed, if it was installed for the whole machine or just for one user. And we can also see the install location here. When you scroll a little bit further, we can see all updates on this machine. So you can make sure that your machines are properly served with Windows updates, for example.
That's really cool. And that's on an individual machine. If I wanted to look at the applications that are being deployed in my estate, is there another dashboard that would show me that?
Yeah, sure. So for this use case, you would open up the application inventory dashboard. So just doing it right now. Again, we have some information about the top 10 most popular apps. Like in this case, Firefox has an install count for 20 here. Or on the other hand, we can see the top 10 most popular vendors or publishers. And let's say we wanted to analyze this particular app here, Adobe Reader DC. We can already see that we have 15 installations here. We have 8 hosts where it is not installed. We have 3 different versions, 1 language, and 3 different install locations. Just click on it to go a little bit deeper here into the single application inventory dashboard. Then again, we can see we have 3 versions of that application. Here we can see the versions and the install locations. And when we scroll back to the bottom of the dashboard, we can see where this application is not installed. So with that information, we could maybe close the gap of where our deployment did not succeed. Now, on the other hand, it's good to know when or which applications are really used by our users. Therefore, we have our application usage dashboard. Also located under the applications menu. And we give it some time to load. Then there's information about how many individual applications are seen in this IT infrastructure, how many different versions, how many users, and how many hosts. And then we can see which applications are in the foreground. So uberAgent is able to determine which application has the focus, meaning which application receives the, for example, keyboard input. And this is exactly what you can see in this time chart. So in a percent value, you could see that, for example, here right now, 10% of our users are using Visual Studio Code. When we scroll further, we can see some information about the most popular apps and which are in the foreground. The same is true for processes. And when we scroll further down, we can see the application usage by apps. Now, again, let's click Adobe Reader DC to see when the application was used. So here we can see the usage went up and no one used this app. And then today at 8 a.m., 40 users started using this application on 15 hosts. And then we can see the number of users running a particular version of that app on how many hosts. And here's the real key information: which user is using which information on which host. And with that, you could make sure that you're, for example, not paying license fees for applications that your users aren't using. Or another use case would be to utilize this dashboard when doing migration planning, so that you can determine which apps need to be migrated to another platform, for example.
I suppose it also, from a troubleshooting perspective, if one user was having an issue with an application or a report, that you could look at the difference between two users in a department and see that they're both using different versions of the application, and migrate one user to the later version, for example.
Yeah, absolutely. This could also be a very good use case here.
Brilliant.
Now, when sticking to the application usage, we can do this for classical installed applications, but also for web apps, because we believe it's very important to keep an eye on the web apps itself, because more and more applications are shifted from classical installed applications to web apps. And that's why uberAgent has a browser extension that is available for Chrome, Edge, and Firefox. And with that extension, you can monitor what's happening inside the browser. So let's just choose my filter here. So my machine in the last 15 minutes. And as you can see, in the last 15 minutes, I was just looking at my Splunk instance. So uberAgent is also able to determine which tab is really used by your users. In this case, or with this information, you could also get those trends here, like which web apps are really used by your users, which browsers are used to access these web apps, and also the number of users running a web app or the number of hosts running a web app. At the bottom, you can see information about when the site was used. A little bit boring here because it's just my host, my user, but I think you get an idea what this time chart is showing you. At the bottom, you can see the host name, the username involved, which browser and which browser version was used to access this web app. But what is a little bit more interesting than just the usage is the performance of a web app. Now, therefore, let me just open this dashboard here. Again, entering my browser, so we're looking at real data. So again, these were the loading times when I reloaded the dashboard. So you can see W2022, my Splunk instance here. And we can see that, for example, the latest loading time was 1.9 seconds. So this was how long it took to load a page. But as you can see, I also have my presentation open here, my Google Calendar, and my inbox. And these sites are constantly refreshing themselves by doing XML HTTP requests. Now let's have a look at these. And here you can see that mail.google.com did something here, calendar.google.com as well, and docs.google.com as well. So there's always something going on here, while I did not intentionally reload those pages. Let's switch back to that view and highlight a different use case. So when we want to analyze, for example, a real website here, nbcnews.com, we just open it up, we can see that loading icon here, and now we move back to the dashboard. I need to wait a little bit to get this information in the dashboard because uberAgent sends data every 30 seconds. Now let's see if we waited long enough. Unfortunately, not yet. Sorry. There it is. We can see nbcnews.com had a loading time of 6.2 seconds. Now, you might have spotted that I have my ad blocking system enabled here. Let's do the same without having uberAgent enabled. While the page reloads, I go a little bit deeper here to show the following. We can see the tab URL nbcnews.com here, the page load duration, and then when we focus on this entry here, the 7 in request URLs, we can see that while we browsed only to nbcnews.com, 7 additional URLs were requested. So something related to cookies here, some other websites were used here. I absolutely don't know what they do, but I'm nearly 100% sure if you would Google them, you would end up having something advertisement related. Now let's refresh the dashboard as we have just reloaded the page without having the ad blocker enabled. So now we see 13 request URLs here. So we can see that a little bit was really blocked by uberAgent. So for example, here we see something script related, some personalized things. So we can really see that the ad blocking system did block some adware or nearly spyware related things. And this is one of the use cases you could do with the browser extension. But another use case would be to monitor the backend performance from the client. So let's open up the dashboard or another dashboard here by just opening the IP address of my Splunk server. So I browsed to this dashboard using the IP address to make sure we see a different bar here, a different entry. Now, while we wait for this entry to come up, or here it is, 2.5 seconds initial loading time. And in the background, I'll put some load on this machine by using a little tool called CPU stress to do exactly what the name indicates, stress this machine. And now I'm going to reload the dashboard. You can see it takes a little bit longer to load. Right? Search is waiting for input. Not everything is responding like it did before. You can see it's really taking longer. Now I'm going to stop the CPU stress here. Then let's see what data we've got here. So initially we had a loading time of 2.5 seconds, and then with a little stress on the machine, we had 3.2 seconds. Still very fast, but the thing I want to stress here is that a backend that is under heavy load can absolutely influence the user experience. So if the backend is has no resources left, it negatively affects your users.
Yeah, I really like this, Julian, because again, it's not just showing the web browser, the performance of the web browser, it's actually showing the individual tab of within that web browser and the performance of potentially each of those applications that you're showing.
Exactly.
And then again, the back end of each of those applications.
Yeah. And by the way, this is not only true for web apps, but also for classical apps, right? If your application server has no resources left, this could also influence your user experience. So this is a very important thing to keep in mind here. And also, I think I said it in the introduction, uberAgent is really flexible. So you can choose which web apps should be monitored, or if you want to, you could also maintain a deny list so that you don't even monitor certain web apps for example, for compliance or security reasons.
Okay, and in the introduction, you mentioned that uberAgent can be installed on physical devices, and we've seen that in this demo. But what if those physical devices are laptops, so they're not, they're moving around in airports or in different customer sites? What happens to the data when the uberAgent's offline and sort of can't connect to that back end infrastructure?
Yeah, also a good question. Let's move back to the slides here again. For this purpose, we have our persistent output queue with intelligent disk buffering. So I have a few graphics for this. So usually uberAgent buffers its data in RAM before sending it off to the backend. Now, exactly the use case you described, what happens if the backend connection is lost. uberAgent notices that and switches to a local SQLite database on disk. So it writes all the events to disk. And once the connection to the backend is up again, it sends all the data that were stored in the SQLite database and switches back to automatically sending directly data to the backend. So with that, we make sure that no events are lost, even when the connection to the backend is lost. And this is not only relevant for Splunk, but also for Azure backends, for example.
Okay. Is there a time period for that? How long it would actually hold that data in the disk buffer?
It is fully configurable. So you can decide for how long you want to maintain the data or how many database files should be created. So that's completely up to you and your needs.
Okay. And I know you've helped customers sort of configure and deploy uberAgent to tens of thousands of devices. So with the agent being available for the various platforms as well as the endpoints, do you have any sort of tips or sort of configurations that you could go through about how our sort of customers and end users could deploy uberAgent to those massive scale of endpoint devices?
Yeah, absolutely. So uberAgent has various configuration options. So first, there's a text-based configuration sitting right on the endpoint. So a local configuration file. And obviously, the benefit of a text file is that it can be adjusted easily. But it's only good for like small POCs, right? So shipping all those configuration files to tens of thousands endpoints is very unhandy. The next option would be to configure uberAgent with group policy objects. So we provide a GPO backup and GPO templates with the download bundle. So you can configure the agent via GPO. The benefit of GPO is that it is well established in basically every enterprise environment, but it is a good way to distribute individual settings, or only a good way to distribute settings. So especially when configuring uberAgent ESA, it's quite unhandy because you still need to maintain those local configuration files somehow. Therefore, you might need additionally to GPOs like a way to distribute those files. So that's also not the best option here, because GPOs are simply not built to distribute sets of files. Instead, we created another feature that is called central config file management. It's our approach to combine the benefits of local config files and group policy objects. It's an agent-based pull mechanism where it pulls like its configuration archive from an SMB share, where the whole configuration bundle is shared for all endpoints. And it's also it's offering like a configuration flexibility. So you could publish different configuration archives for your different uberAgent versions, but also different configuration needs. Let's say you have department A that requires only the hardware inventory, then you could create a specific configuration set just for this department. And with that, you can like publish configurations depending on location, department, or other properties. And the central config file management is built for scalability. So it has a high performance aspect and uses like nothing of resources. And it's also caching a local copy from the SMB share. And additionally, the SMB share is only accessed for configuration checks refreshed. So these occur at a randomized interval to evenly distribute the load on the share. And therefore, it's also very important to monitor which endpoints use which configuration bundle. So on a Splunk dashboard, you can see, for example, from which SMB share the configuration was loaded, when it was applied, and so you really have an idea of what your agents are configured to do. And finally, our recommended configuration option is using the central config file management, because it eases the whole configuration for an entire IT infrastructure.
If I wanted to look at an individual user session performance, so how are user sessions performing, what the user login has performed, could you go through that within the uberAgent dashboard for me?
Absolutely, yes. So let's say we go into the user sessions dashboard here. Just give it some time to load. You always have the option to filter here. So we provide various filtering options, as well as selecting a time range. But let's filter for just one host here, my host. Then let's have a look at the user session that is currently active on my host. So you just click on the line and Splunk will take you to the Analyze Data Over Time dashboard here. So we can see the host, the username, the session ID that is assigned to this session, when was the logon, when was it seen for the last time. If it was a remote session, we would see those remoting information here as well. In this case, it's a local session. Then we have the ability to compare metrics over time, like, for example, the session CPU usage in percent with the working set memory. We could also analyze the average disk latency caused by this user session, the session connection state over time, or if there was input delay over time. So you can compare the maximum input delay with the average here. To conclude this user monitoring, I'd also like to talk about the user log-on duration dashboard. So as I mentioned in the introduction, uberAgent can measure user sessions, obviously, but also the log-on duration. So therefore, we have this dashboard. We have some averages for all log-ons here, like the total duration, how long it took to load the user profile, group policy, to process Active Directory logon scripts, group policy logon scripts. So all those averages for all sessions. And these values are also shown in this time chart here. And this already gives you the ability to see if your potential changes to your infrastructure had a good or bad impact on those loading times. So let's say we want to analyze one particular session. We just click on the line and we get to the new dashboard. And I think you already have an idea how those dashboards are structured, or how our dashboards are structured. At first, there's this high-level information, and as soon as you get to the bottom to the dashboard, there's nearly always an option to go on to the more detailed dashboard. So let's get back to this dashboard here, the single log-on dashboard. So there's information about the username, the host name, again, which session the session ID is assigned, and the logon duration. And then uberAgent measures the times for the main phases of a logon. So for example, how long did it take to load the user profile, to process the group policies, to execute an Active Directory logon script or a group policy logon script, and finally, how long did it take the shell to start? Then there's also information about the Active Directory here. So to which site we are connected to, which is our authenticating domain controller, how long did it take to find this, and the configured group policy loopback mode. Then when we scroll a little bit further, we can see all group policy client-side extensions that were executed with their GPOs. So we can see that, for example, group policy drive maps took 7.81 seconds. We can see that it was executed by this GPO drive mappings. And we can also see the return code of the GPO. So with that information, we can make sure that our group policies are applied as expected. On the right, there's a visualization of those loading times for the client-side extensions. And then when we scroll a little bit further, we can see all processes that were active during the logon. So at first, there's a little illustration of the life cycle of the process. We see the category, the process name. And for example, if we focus on this one, so a PowerShell.exe that got called with a group policy logon script, we can see the command line of the PowerShell. So in this case, we can see that xanapp_logon.ps1 was executed in this logon. And this has not only a performance aspect, but also a security aspect, right? So if an attacker got access to a user account, you certainly want to analyze which processes were executed by this user or in this user's context. And with this, it's possible. So really detailed information about the user logon, which is available for local sessions, but also for sessions using ICA, so Citrix sessions. I think with that, I'd like to conclude this little presentation here. So thanks everybody for tuning in. I hope you've got an idea of what uberAgent UXM is. So to summarize it, uberAgent provides rich metrics, not only on virtual, but also physical endpoints. And it provides metrics or insights into various perspectives, right? On the machines, we have several information. Then on user sessions, then there's a lot to discover around applications and processes. then uberAgent is also monitoring the on and off transitions, and especially for SBC or VDI use cases, we have a lot to discover here. And with that, I'd like to hand it over back to you, Stephen.
Brilliant, fantastic. Thank you, Julian, for an amazing session. I've definitely come away understanding a lot more about uberAgent, and definitely understanding. I didn't realize that it supported the browser capabilities. So that's something I'm going to look into. So with that, I'd just like to again thank Julian for his time today, and I look forward to catching everyone on the next Citrix Masterclass.